Good morning students. So today we will discuss about the new chapter electric charges and electric field. So first we will discuss about the basic concept electricity. So what is meant by electricity? So it is the branch of physics which deals with the study of charges. So that is called what electricity, and it is divided into two branches. So first one, electrostatics, or static electricity. Another one is current electricity. So once again, electricity is a branch of physics which deals with the study of charges, and it is divided into two branches, electrostatics or static electricity. Another one is current electricity. So first, electrostatics. So it is a branch of physics which deals with the study of charges at rest. So that is called what? Electrostatics. So current electricity means again it is a branch of physics which deals with the study of charges in motion. So that is called what? Current electricity. So now we'll coming to the main point, electric charge. Electric charge. Electric charge. So it is an intrinsic property of the material which exerts electrical force, and it responds to the electrical force is called what? Electric charge. So the SI unit of electric charge is SI unit of electric charge is coulomb, and it is denoted by the C, isn't it? So that is called what? Electric charge. So now we'll discuss about very important for 2 marks, properties of electric charges. Properties of electric charges one by one. So there are two types of charges, positive charge, another one is negative charge. So there are two types of charges, positive charge and negative charges. Second property, like charges are repelled to each other while unlike charges are attract to each other. So for example, plus Q and plus Q. So these are like charges, and minus Q and minus Q. Again these are the like charges, isn't it? So plus Q and minus Q. So these are the unlike charges. So like charges are repelled to each other while unlike charges are attract to each other. So that is the second property. Third property, charge is conserved. Charge is conserved because charge can neither be created nor be destroyed. So fourth property, charge is quantized. Charge is quantized. So Q is equal to plus R minus NA. So it is the number of multiplication of the electrons, where N is the number of electrons. So E is the charge of an electron. So charge of an electron value is 1.602 into 10 to the power of minus 19 coulomb. So next property, charge is additive in nature. So charge is additive in nature. So these are the very important properties of electric charges. So it's 2 marks, very important. So one by one, once again, So there are two types of charges, plus q and minus q. So like charges are repel to each other, while unlike charges are attract to each other. Third property, charge is conserved because charge can neither be created nor be destroyed. Hence charge is conserved. Then charge is quantile. So q is equal to Ne. So the charge of an electron is equal to 1.602 into 10 to the power of minus 19 coulomb. And last property, charge is additive in nature. So it's very important for in your examination point of view. So once again, what is meant by electric charge? So it is an intrinsic property of the material which exerts electrical force. So the SI unit of electric charge is coulomb. Then you can write the properties of the electric charges. So next concept is Coulombs law. Coulombs law in electrostatics. Right, next very important concept is Coulombs law in electrostatics. So very important, Coulombs law in electrostatics. So let 2-point charges. So this is the q1 charge and this is q2 charge. Let 2-point charges q1 and q2. So the force of attraction or repulsion between 2-point charges is directly proportional to the product of magnitude of 2-point charges and inversely proportional to the square of the distance between them. So the force of attraction or repulsion between the 2-point charges is directly proportional to the product of magnitude of 2-point charges q1 and q2 and inversely proportional to the square of the distance between them. So F is proportional to magnitude of q1 q2 by r square. So we can remove the proportionality, then we can write constant. So F is equal to k into magnitude of q1 q2 by r square, where k is called what? Coulombs constant, where k is Coulombs constant. So and its value is k is equal to 1 divided by 4 pi epsilon naught, where epsilon naught is the permittivity of the free space and its value is epsilon naught is equal to 8.854 into 10 to the power of minus 12, isn't it? So substitute the k value in this equation. Therefore F is equal to 1 divided by 4 pi epsilon naught into magnitude of q1 q2 by r square. So this is the Coulombs law in electrostatics. Once again, the force of attraction or repulsion between the 2-point charges is directly proportional to the product of magnitude of 2-point charges and inversely proportional to the square of the distance between them. So we can remove the proportionality, then we can write F is equal to k into magnitude of q1 q2 by r square, where k is Coulombs constant and k value is equal to 1 by 4 pi epsilon naught, where epsilon naught is the epsilon naught value is 8.854 into 10 to the power of minus 12. So then F is equal to 1 by 4 pi epsilon naught magnitude of q1 q2 by r square. So this is the statement of Coulombs law in electrostatics. Now we'll discuss about Coulombs law in vector form. Coulombs law in vector form. Coulombs law in vector form. So X, Y and Z. F12, F21. So A, B plus Q and minus Q. So R1, R2, R21, R12. So let the position vector of 2-point charges plus Q and minus Q be the R1 and R2 respectively. The vector is leading from A to B. So the vector is leading from A to B. So AB is equal to, so this is Q1. So this is Q2. So Q2 minus Q1 is equal to R2 minus R1. In the same way, the vector is leading from B to A. So we can write, so BA is equal to Q1 minus Q2 is equal to R1 minus R2. So the magnitude of R21 is equal to R21. The magnitude of R12 is equal to R12. The force on Q2 due to Q1 is denoted by the force F21. So therefore F21 is equal to 1 by 4 pi epsilon naught. So Q1 Q2 divided by, so Q2 to Q1 means what? We can write 2 to 1. So R21 square into R21 cap. So this is equation number 1. Similarly, the force on Q1 due to Q2 is denoted by the force F12. So therefore F12 is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R12 square into R12 cap. So this is equation number 2. So therefore finally F12 is equal to minus F21. So this is the Coulombs law in vector form. Once again, let the position of two vectors Q1, Q2 be the R1 and R2 respectively. The vector is leading from A to B. So AB is equal to Q2 minus Q1 is equal to R2 minus R1. In the same way, the vector is leading from, so B to A. So what happens here? Q1 minus Q2 is equal to R1 minus R2. So the magnitude of R21 is equal to R21. The magnitude of R12 is equal to R12. So the force on Q2 due to Q1 is denoted by the force F21. So therefore F21 is equal to 1 by 4 pi epsilon naught Q1 Q2 by R21 square R21 cap. So cap is a unit vector. Similarly, the force on Q1 to Q2, the force on Q1 due to Q2 is denoted by the force F12 is equal to 1 by 4 pi epsilon naught Q1 Q2 by R12 square minus R12 cap. Again R12 cap is a unit vector. Then finally, so F12 is equal to minus F21. So this is the Coulombs law in vector form. Next one, electric field. Electric field, it is denoted by E. The force experienced by the moving charge, the force experienced by the moving charge is called what? Electric field. So E is equal to F by Q. The force experienced by the moving charge placed at that point is called what? Electric field. So E is equal to F by Q. So the SI of electric field is, so the SI unit of electric field is, so we can write what is the SI of force? It is Newton. So the SI of charge is Coulomb. So Newton per Coulomb. Or alternatively you can write, so Newton per Coulomb. So the SI of electric field is Newton per Coulomb, isn't it? So it's very important for 1 marks. So next one, electric field lines. Electric field lines. So electric field lines means, so these are the imaginary lines. These are the imaginary lines drawn along the motion of an isolated positive charge is called what? Electric field lines. Once again, so these are the imaginary lines drawn along the motion of an isolated positive charge is called what? Electric field lines. Next very important concept is properties of electric field lines. Properties of electric field lines. So one by one. So they are always starts from positive charge, end on a negative charge. So first property, electric field lines, they are always starts from positive charge, so end on a negative charge. So that is the first property. Similarly, second property, they have no physical existence. So that is the second property. Then third property, electric field lines cannot intersect with each other. ಯಾವುದೇ ರೀತಿಯಾಗಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ಗಳು ಏನಾಗಲ್ಲ, ಇಂಟರ್ಸೆಕ್ಟ್ ಆಗೋದೇ ಇಲ್ಲ. ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಕೆನಾಟ್ ಇಂಟರ್ಸೆಕ್ಟ್ ವಿತ್ ಈಚ್ ಅದರ್. ದೆನ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಡು ನಾಟ್ ಫಾರ್ಮ್ ಎನಿ ಕ್ಲೋಸ್ಡ್ ಲೂಪ್. ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಏನಾಗಿಲ್ಲ, ಲೂಪ್ ಫಾರ್ಮೇಷನ್ ಅಲ್ಲಿ ಇರೋದಿಲ್ಲ. ಸೊ ದೀಸ್ ಆರ್ ದ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ field lines. So suppose draw the diverging field lines around a unit positive charge. How to draw the diverging field lines around a unit positive charge? So first we can write positive charge. So diverging. So diverging means outside arrow mark. So diverging field lines around a positive charge. Similarly, draw the converging field lines around a negative charge. So converging means arrow mark rotation, this like. So converging field lines around a negative charge. Suppose draw the electric field lines around two equal and opposite point charges. So positive charge and negative charge, you can write this like. So draw the electric field lines around two equal positive point charges, this like. isn't it? So once again, what is meant by electric field? The force experienced by the moving charge placed at that point is called what? Electric field. So E is equal to F by Q. So the SI unit of electric field, the SI unit of electric field is Newton per Coulomb. Next, very important for 2 marks. So properties of electric field lines. So first property, so electric field lines, they are always starts from positive charge and on a negative charge. They have no physical significance. Then third property, electric field lines cannot intersect with each other. Then fourth property, electric field lines do not form any closed loop, isn't it? So these are the properties of the electric field lines. Then draw the diverging field lines around a positive charge. Draw the field lines around a negative point charge. So draw the electric field lines around two equal and opposite point charges, and draw the electric field lines around two equal point charges, isn't it? So next class I will continue.